Right. So last meeting we talked about concave and convex mirror. So in this topic, we describe the images that is formed in a concave and a convex mirror using the ray diagram and the mathematical way, or so the lens equation or the mirrors equation. I mean, so in describing it, and we have discovered that the mathematical way of solving it is the most accurate way of describing an image formed in a concave or in a convex mirror. So today we will going to proceed to the second property of light, which is what we're referring to as the property refraction. So once we talk about refraction, um, how or what is the nature of light in refraction? Any idea? Let's have from Kian.
So, light refracts when it travels to a different medium from what it traveled before. So,
Okay, so it's refract.
so it
Once it's
changes,
traveled, it changes what?
light changes direction when it refracts.
Okay, so light travels or refract once it's traveled from one medium into another. So this one, once we talk about refract, there is a bending, right? Bending of lights. And Kian said that it once it will travel from one medium into another, it refracts because it changes its direction. And what causes the change in direction? Why? Why is that so? Once it will travel from one medium into another. Just like your pencil, as at the very start of the lesson in this chapter, I we have a pencil inside the glass, right? So what have you observed? You have observed that the pencil is quite broken if you look at on the surface, which is on the boundary of the water and the air. You will see that the pencil is quite broken. That is refraction. There is a bending of lights. Okay, what causes of light to bend? Why? Once it moves from one medium into another. Hmm? Ano ang naga-cause? Anybody? Uh, let's have from Lyndon. Lyndon, do you think what is change in light once it will move from one property, from one medium into another?
Ang optical density na, sir.
The optical density is on the material itself, right? There is a change or there is a refraction that causes an object that causes the light to refract because of the optical density. That's correct. Because one medium to another could have a difference in optical density. Just like your air and water, your air is less optical density compared to water. That's why once your light wave will move from air into water, there is a slight difference or there will be a change in the direction. So my question is, what is in light that changes once it moves from one optical density into another optical density medium? Ano ang
There is a change in speed, sir.
correct, Rens? So here, the speed changes, okay? So the light speed or the speed of light changes as it moves from one medium to another. Okay, so nag-ailis ang ana nga speed once it moves from one medium into another. Lyndon said that the speed of light or the light class once it enter from one optical density into another, there is a refraction. So ano ginanamin natin kang optical density? Just like your density of water, density of metals. So here, it has an ability to refract, okay, to decrease the speed. A greater optical density could decrease more speed of light compared to a less optical density. The speed of light class in a vacuum is 3 times 10 raised to 8 meter per second. That's the speed of light in a vacuum with a symbol of letter C. Now, let's say, for example, we have here your medium. Let's divide this one. Okay, so this could be your air here, and this could be your water. So this is your water. Okay, and then let's put a normal line. Okay, the normal line must be always perpendicular to the boundary, just like in your mirror. Okay, so let's say, for example, we have a light, or yeah, so let's have here, this is your angle, which is called as the angle of incidence. The angle theta is the angle of incidence there, measured from the normal line. Now, air is less in optical density to water. So the tendency class of the light ray, once it enters the water, it will refract towards here, towards the normal line. You will see this is the angle theta, which is the angle of refraction. You will see that the angle decreases as it bends or enters the water. It's because water's optical density is greater than air. Okay? So what happened on the speed? The speed of light, once it enters the water, decreases. Amura nga nagtiko. That's why there is a change in the direction, because the speed here is lesser, okay, compared to the speed in air. Now, let's have to consider this condition. If light ray is moving from less dense to more dense medium, your angle of incidence is greater than the angle of refraction. Okay? But if it is traveling, this is, for example, air to water, from more dense, okay, from more dense to less dense, okay, your angle of incidence is less than the angle of refraction. Okay? So, ang muna tatandaan. So, example of this is if light is coming from the water going up to the air. Okay, so light wave is coming from the water going up to the air. So, baka mo nga sa ano why you can see the surface of the water in a clear water. Okay, light wave is coming from the surface going to up to the air, to your eyes. So baka nga, there is no source of light at the bottom, but then reflection is also happening there. So if the light coming from the sun enters the water, it will reflect back towards you. That's why you can see the surface of the water down. So the direction of the light wave now is from more dense to less dense. That's why you can see the surface of the water. So this is now the nature of refraction. Okay, so this one could be described in a certain law, no, in a certain law, and what we call as the Snell's law. So the Snell's law states that the sine of the angle I all over the sine of the angle R, or the ratio of the sine of the angles of incidence and refraction, is equal to the ratio of the velocity in the first medium divided by the velocity in the second medium. This is how the Snell's law described here. As you can see, Once it enters here, you will have a velocity, okay? A velocity 1. Usually, your air is tawag natin, slightly just different from the vacuum, but it almost equal to the vacuum. Now, once it enters the water, it will have a new velocity because of the optical density. So we have your velocity 2. So the ratio of this angle of incidence, the sine of it, and the angle of refraction, the ratio of that is just equal to the ratio, is that also equal to the ratio of the velocity in the first medium divided by the velocity in the second medium, right? Okay. So we're talking about optical density a while ago. Gamba kita ka naka-optical density. And optical density is an ability of the material, a transparent material. You know it already, that the transparent material has only the ability to refract. Okay. Transparent material to refract light or to decrease the speed of light. The more dense the material is, the transparent material is, the greater the decrease in the speed of light, right? So this ability class or this optical density is measured in terms of its index of refraction. Okay. Your index of refraction is referring to the amount of light that is refracted. Okay? Ano ka duro or ano ka grabe ang ana nga refraction. Ano tawag nga index of refraction. This is actually measured in with a symbol of N as the index of refraction. This is the ratio between the speed of light divided by the speed of light in that certain medium. The speed of light in vacuum divided by the speed of light in a certain medium. So index of refraction is somewhat related to the optical density. So each material, each transparent material has its own constant optical density. It was measured in index of refraction. Let for example, your air. Your air optical density or index of refraction is equal to 1.003. It is almost equal to 1. That's why if you're going to use this in problem solving, we just have to use 1. Okay? Your water optical density is 1.33. So quite bigger than compared to air. Your eye's optical density or index of refraction, I mean, is 1.31. So you will see ice is less dense compared to water. So the optical density of ice is quite that smaller compared to water. Okay? Diamond has the highest optical density with 2.42. So jamo-jamo man and whether you're dealing with that certain stone, whether it is a diamond or not, because of the optical density or the index of refraction. Your glass, your crown glass is only 1.51. But some of the glass which are flint, mga damol, mga ano mga glass is 1.63. So, kung usually ang flint glass nga diya ginasalaan natin as diamond kung i-carve ta na peke, no? So, diamond is 2.42. It's quite big difference. So you will see here this index of refraction of the following materials. If we will have a test, no, on problem solving, and if the problem is giving you not listed here ang index of refraction, I'll just to give the index of refraction, which is the constant. Now let's relate the index of refraction to Snell's law. So if n is equal to c over v and v is equal to c over n, okay? So definitely here, sine angle I all over sine angle r is equal to c all over n1 c all over n2, right? We replace this one here with this. So because c is constant, we can cancel it out. So definitely sine angle I all over sine angle r is equal to n2 all over n1. Okay, so this is now how your Snell's law related to the index of refraction. Any question with that? Okay, so let's have to solve a certain problem. Okay, so for example, we have here a problem. Okay, a beam of light enters a block. Okay, enters a block of ice at an angle of incidence. Angle of incidence of 30 degrees. Okay, what is the angle of refraction? Right. So let's say, for example, this is the ice. Okay. Then we will draw the normal line, which is perpendicular as always. No, index of angle of refraction. Sasalad ka isa ang ating inanamin. All right. So we have a light ray. And we have here the angle of incidence, which is 30 degrees. So it will bend towards here. Ngayon lang, sala ako ng drawing ta. Dapat dyan lang natin sa ice. Kay ice lang mo. Right? And let's have... And this is what are we solving for? Angle of refraction. So our formula, class, is sine angle I all over sine angle R is equal to, N2, it's N2 all over N1. Let's have to put the given first. The given in the problem is the angle of incidence, which is 30 degrees, your N1, which is air, and N2, which is ice, 1.31. So these are the given in the problem. So we're after for the sine angle R. So with this, we could have come up with sine angle R is equal to sine angle I multiplied to N1 all over N2. I hope my formula is correct, no? And I'm sure it's correct. So angle R is equal to sine 30 degrees multiplied to 1 divided by 1.31. The second function of it, sine -1. So angle R, therefore, is, can we solve? And give me the answer. Okay, what is the answer? Is your answer 22 degrees? Do we come up with the same answer?
22.4, sir.
Okay lang, 22 degrees. So we'll just round off. So 22 degrees is the angle of refraction. Okay, can you follow? Okay, so let's have another problem. Let's say, for example, we have here a glass. No, let's have a glass. Let's have the color, okay, violet for the glass. So let's have a glass here. And your glass index of refraction, this is your glass index of refraction is 1.6. Now, if, for example, your light wave enters the glass at an angle of 45 degrees here. Now, the question is, what will be the angle once it will pass through the glass? What I am trying to say is, if it will move from the other side of the glass, so what will be the angle of refraction? Ang question, Rejal magwa pa na pira ang angle of refraction na. Okay, sa banta nyo pira ang angle of refraction na. Kunyan ta na maagi.
45 man gyapon, sir.
45 man sa gihapon. That is correct. But we will going to prove it. Okay? I-prove natin nga 45 man sa gihapon. Okay. So here, you will see that this will bend inward and it will move here. So this is your angle of refraction. And let's put another line here. And this will now becomes your angle of incidence, which is equal here. Okay. And let's have to move it outside. There. So definitely, amo diyang ginaas natin. Is this 45? We will see. So let's have first to deal with this. On the first part, your N1 will be your air. This will be your N1. Your N2 will be your glass. Okay. And the angle theta, or the angle of incidence, is 45 degrees. So your angle R is equal to sine angle theta, angle I, multiplied to N1 all over N2. So your angle R therefore will be equal to, so this will be equal to sine 45 multiplied to 1 divided by 1.6 shift -1 sine. Okay, so your answer will be equal to, my solution here is 26 degrees. Okay, so this one will be 26 degrees, and this one will also be 26 degrees. So therefore, in the second case, in the second scenario, let's have here already from the glass going out to the air. So your N1 now will be, so your N1 now will be 1.6. Your N2 is 1. Your angle your incident angle is equal to, so your incident angle or angle of incidence is equal to 26 degrees. So let's solve. So your angle R will be equal to sine angle I multiplied 2N1 all over N2 sine -1. So your angle R will be sine 26 times 1.6 all over 1. Tapos That will be sine -1. In my calculator, that is equal to 45 degrees. So therefore, you will see that the answer is also 45 degrees and our prediction is correct. So, ang atin gina-predict nga it will be 45 degrees when it will come out from the glass, it's correct. So this is how we solve it. Right? So, question? Any question? So that we can proceed? Okay. So let's proceed now. Now we will have the two the two phenomenon that we actually
Sir.
observe. Yes. Yes.
Ang normal line, sir, perpendicular at anagit sa din
Uh, uh,
sa
kita mo
ano sa
permi
glass or
sa ano sa boundary ka darawa ka medium. Okay?
so kung
Kita mo gid
kapatindad ka na,
perpendicular.
sir,
Jabang diri na mo nga. Gets mo? Amo na mag-u ka mo gid babatang ko. Kay tidya ako mo nagbatang kang ano. Diya ako nagbatang kang ano. Para nga parehas batana kung diya ko karon mabatang kag mag-amo karay malusod diya sa piyak babatangen ko data nakatindig so matalang pa kamo. So amo na nga diya ako nagpaagi ka akin nga drawing sa kilid ka glass. Okay? Okay ren? Basta perpendicular kita na permi sa boundary. Sa boundary ka darwa ka medium. Okay, darwa ka media. I mean, the plural of medium is media. Okay, so let's now proceed on the two phenomenon. Now we all actually experience and observe this, but the concept of refraction is present. So Kaina, I am talking about the the depth of the water, no, the depth of the water. Siguro you have encountered what have you noticed on the depth of the water once the water is so clear, no? What have you noticed on the depth of the water when you look at it on the top? Sa babaw ka lang, you're not in the water, ha? You are on the top of the water. You are in air. So what have you noticed on the depth of the water? Anong na-notice ninyo? May na-notice ka mo? May na-obserbaran ka mo? May na-obserbaran ka mo?
sabaw ka na lang tawon, sir.
Ano na?
Sabaw ka na lang tawon, sir.
Daw nabaw, tana lang tawon. Okay, I have an experience with that. When I was in college or high school, we went to a certain place in Hamtik. No, ang Ingwan, Blara, Ingwan, Batangan, ano ka to, Ingwan Falls. Then, when we walk from Poblacion 5 to that area, there is a one part there that you are going to cross the Suba, no, the river. So one time I thought that that certain area is just malatuhod lang. Sabi ko malatuhod lang. Ang ending pang tusmaw ko, baw tagahawak dali nung nga patakabot sa falls basta taken rin. So ay na full ako kang height kang tubig. Amo ra sa swimming pool, amo ra barantayan mga bata. Kay sometimes abira ka mga bata nga nabaw pero pag tusmaw na dalem gali. Kay it's because of that phenomenon is called as the apparent death. Apparent. Though it's just a fake death, no? Kaysa panalakan mo lang ratana. Okay, because what is happening? Like for example, we have here, let's have here your fish. If you want to spear a fish and you look at the fish, no, diyan ka sa babaw, makita ka nga isda. Okay. May nakita ka nga isda. Here. Diyan mo nakita ang isda. Now, actually, this is not the real position of the fish. If you were going to put here the normal line, the fish is actually located pa in this portion. Kung dya imo mata ha, dya imo mata. Okay. So, ang isda located dya patanatana ka na. May balis ka. Dapat ang illusion ang naga broken line. Wait lang ha. This one must be a broken line. Okay. Um, Actually, the actual position of the fish is at the bottom pa. Makita mo tana, this one. This is the, mabakaw, the fake position. Kay nagnabaw tana. Why is this happen? Now, you will see that this will be your eyes, no? Diyang imo mata. This is the light wave coming from halin sa dalim. So, it will actually bend towards your eyes. Ga-increase ang aton nga angle of incidence and angle of refraction. Pero, ang aton panirkanta na, wala na talaga tiko. So, matadlong lang tanara. It will just actually move here. So, you will see that the fish is located at the bottom, but you've seen that on the top portion, daw nabaw. So, if you want to sphere the fish, do not sphere it here in the actual location kung di mo nakita. Hindi. Dapat sphere mo tana sa dalim pa. Kaya kung diya ka ma-sphere, hindi mo na maigo. It's just the image. It's just the illusion. But if you're going to sphere it at the bottom here, maigo mo ratana. Because that's the actual location of the fish. This is what we call as the apparent depth. Now, we were going to have a mathematical way of doing this. In the apparent depth, we are dealing with a very small approximate angle. In a very small approximate angle, the ratio of angle tangent angle I over the tangent angle R is just equal to sine angle I all over sine angle R. They are just equal, no? Ang ratio. Now, if, for example, we have here the measurement from here up to here is your x. It's the measurement of the distance of the fish from the principal axis. And you will have the height of the fish from here. This is the height of the fish, which is the image of the fish. And from here is the actual height of the fish. So in this case, class, your tangent I, or a small approximate angle, is equal to the ratio of x all over h. Okay. And tangent r, angle r, is equal to the ratio of x all over the height of the image. So with these findings, your tangent, yeah, your the ratio of it, which is tangent angle I all over tangent angle r, is equal to x all over h, x all over h prime. This two is just equal, no? If you can see in my drawing. So definitely tangent angle I all over tangent angle r is equal to h prime, which is the height of the image, h prime all over h, which is the height of the image. All right. So this is now your height of, or the depth of a certain fluid, or of a certain liquid or water, as we talk about the apparent depth. Okay. So I hope that it is clear. Now, how is it related to the index of refraction? You know this already, that sine angle I all over sine angle R is also equal to N2 all over N1. Okay? So definitely, this is also equal to H prime all over H. So N2 all over N1 is equal to H height, height of the image, and so this is now they related on the index of refraction. Okay, I hope that this is clear with you. All right, let's have Okay, let's have an example. So we have, for example, we have a sailor in a yacht. Then he observed that the depth of the water is 3 meters. Okay, ang muna na-observe na. So, gusto na mamanan kung piragid ang actual height of the water. So, N1 is 1, N2 is 1.33. So, if N2 all over N1 is H all over H prime, na H prime all over H, no? Okay. So therefore, height will be equal to N1 times H prime all over N2. So your height will be equal to N1 is 1 multiplied to sakto gid man aton nga formula. Let's see. N2 over N1 H prime over H. So siya ay ginbaal sa iluhon dya sa iluhon to sa babaw.
Yes, sir.
Sakto?
Yes, sir.
Sakto gid man?
Yes, sir.
Ay, sorry, baliskan gali. Ang atong gali nga light wave halin sa dalam, no? So this one will be N1 is 1.33. Okay? Hindi magtalang ha. Bakat sa observation, kita nga tera ka kang tao, kundi ang light wave halin sa dalam. Basta nga apparent depth, alin ang imo nga light wave sa dalam kang tubig. So N2 mo is 1. Okay. So this one will be 1.33 times 3 all over 1. And the height of the water is 4 meters. Again, the direction of the light wave is from the water going to air. Because nakita mo, that's the reflection. Amo na nakita mo. So it reflected from the bottom of the water up to your eyes. Okay, so I hope that this is clear. I will just stop.
There's a given, sir.
Okay, we'll just stop sharing and then I will just end another meeting. It's about to end. I will just make another meeting. Okay.